The data dictionary. Thus far, I think you've determined in my training that in watching the Nugget movies sequentially, we build skills and reapply those skills as we move along our learning curve. And you also notice that I flirt around, to use that expression, quite a bit and drop hints as we move through the training on concepts that we'll cover more fully later on. Well, that's certainly been the case with the data dictionary. I've referenced the data dictionary a lot up to this point. Now it's time for us to formally learn what exactly is the data dictionary, why is it so crucial in Oracle, not only to the operation of the database, because if something happens to your data dictionary tables, your database is going down to the ground immediately, but also we as administrators can access the data dictionary to gain really useful metadata about our system. In fact, we're going to spend time learning how to access the data dictionary views, not only as an administrative user, but also how our ordinary database users can leverage the data dictionary as well. Let's get started. Formally defined, the data dictionary in Oracle Database 11g is a set of read-only tables and views that provide metadata about the database. Now let's take this definition one piece at a time. Read-only means that these are system-managed tables and views, and we're not supposed to be touching them. As a matter of fact, anybody but sys cannot make any changes to data dictionary objects at all. Remember that the sys built-in user owns the data dictionary, so it is possible for a sys user to make edits, but of course we don't want to do that. It would be fairly insane to do that because we're jeopardizing the stability of our database. Tables and views, we understand the difference between these at this point. Our base tables, even in the data dictionary, are hidden from administrators. We instead, as general practice, access the data dictionary by using a number of views that Oracle gives us to use. A lot of those tables and views are represented with synonym names to make them easier for us to remember. Otherwise, some of those views and tables are awfully cryptically named by Oracle. Finally, we have the subject of metadata. Meta is a Greek word that means above, so metadata is data that's above the data or data about data in our database. We can query the data dictionary to look at just about any fact in our database. How much disk space objects are consumed, when objects were created, when they were last modified, security settings, you name it. Whenever you have a question about metadata, you'll want to go to the data dictionary views to get an answer to those questions. Data dictionary views are of two varieties. We have static and dynamic. Static data dictionary views refer to your schema objects, including users. These are pieces of information, or again, to use the term metadata, that aren't dynamic. I mean, once you create a table, its definition, its column names, its constraints, its data storage, its data allocation, all of that kind of stuff remains fairly stable, or if it changes, it happens infrequently, let's say. At least infrequently in comparison to things like network statistics, memory statistics, and this kind of process-oriented schemata, which are tracked with our dynamic views or $V views. Dynamic performance views is what these data dictionary views are called, and dynamic means that that data changes from moment to moment as long as the database is online and open. Certainly, it makes sense, I hope, if you think of something like memory allocation. That is almost constantly going to be in flux depending upon things like the server load of the Oracle server, how many users are concurrently connected, which types of SQL they're trying to run against the database, and so forth. The main point about the data dictionary from an access standpoint that we need to remember are how to access them by grouping or set. We're going to find that in the data dictionary, the main views, at least the static views, are broken into prefixed sets. That is to say, we have what are called the DBA views, the all views, and the user views. Any view that's prefixed with DBA underscore is accessible only to administrative users or users who have the DBA system privilege. Ordinary users, let's say a schema user, is going to be able to query information about either objects that they own and or objects that they have access to by querying the data dictionary views that are prefixed with either user or all respectively. So again, stated as a point of review, the user underscore data dictionary views are filtered to give metadata only about objects that are owned by the calling user. The all underscore data dictionary views, many of which have the same name. The second part of the views is often the same. I mean, if we're looking for column information, we could run DBA underscore columns as an administrator to look database wide at table column information, all underscore columns or user underscore columns, and they're just scoped appropriately. To finish this discussion, the all underscore views give insight into objects to which the user has privileges, not only objects that are owned, but also any other objects database-wide to which the user has been granted one or more object privileges. So as previously discussed, the static data dictionary views are useful for general everyday use. They're going to define things like properties or metadata of every schema object in the database, space allocation info, security metadata. Remember when we learned how to create database users? All of that user metadata is stored in one or more static data dictionary views. Even the data dictionary itself is represented as a view called dictionary, and we can run this SQL statement. In fact, in our upcoming demo, we will run this statement to get a list of all tables across all of those prefixes. And again, to review, the static views have DBA, user, and all, and what we're going to learn in the next whiteboard, the dynamic performance views are prefixed with $. So as I just mentioned, dynamic performance views are continually updated while the database is open and in use. And when you see the kind of data that's tracked by these so-called $, views, that will make sense. Session parameters, obviously that's volatile. It's constantly changing as users connect into the database, as they do work and disconnect, as sessions go idle, as sessions are cleaned up. Memory usage and allocation, again, completely volatile. You can run the view twice right in a row and you'll probably get different results each time. SQL execution, especially in a heavily transaction-oriented OLTP system, you're going to have lots of rich, volatile data there, and just general purpose statistics. Now, why would we use dynamic performance views? We use them for things like performance tuning. Any Oracle DBA worth his or her salt is obsessed with the idea of making the system run more efficiently, run faster, run with greater security and stability. We can leverage the dynamic information to put our finger on the pulse, so to speak, of our running database. The other main reason why we would access DPVs is troubleshooting. When problems do crop up, we want quantitative statistics to back up our troubleshooting strategies and give us grist for the mill. In this demonstration, we'll work with the data dictionary in Oracle 11g. I'm logged into the database as the sys user. I can do that a couple different ways. First, of course, I have to create a connection for sys, which you see I've done. We can double left click the sys connection to instantiate a SQL worksheet in the context of that user. Alternatively, up on the toolbar, you notice the SQL worksheet dropdown. We can pop open a new worksheet under the context of any available connected users. All right, first thing I'm going to do is run a describe against the data dictionary view called dictionary. You'll see that it's pretty simple, actually. It just contains table names and a comments field. Comments are an optional way to document your database objects in Oracle. Now let's run a select star from the dictionary view. We'll order it by table name. Although Oracle just fetched the first 50 rows, if we continue scrolling, there's a lot going on here. Eventually, 700, you see the row IDs. There's lots and lots going on here. And let me scroll back just to show you a little bit about what's happening. Here we have some of the all underscore views. There's just so many of them. Really, my best suggestion for you is, because it's functionally impossible to know or memorize them all, is just do some research online. Read a couple good books on Oracle, depending upon whether you're performance tuning or enhancing the security of your system, whatever it might be, to look for the most important views from the data dictionary for your purposes. Here we come into our DBA underscore views, and just going on forever. Thousands and thousands of rows. We have our $and $GV views. These are our dynamic performance views. We can just keep we can just keep scrolling. But what I'll do instead is on line 7, I'll run another select that I've created, in which we're essentially doing a select splat. This time I'm naming the columns, but we're going to look for table names that include SEQ, which, as we know, is part of the word sequence. As it happens, there aren't that many data dictionary views for sequences. Essentially, you have user, DBA, and all. You'll notice also SEQ. This means we can run a select star from SEQ as a synonym for running user underscore sequences, just a way to save a little bit of heavy lifting text-wise. If we want to run a describe on one of these, why don't we do all sequences? You can see quite a bit of metadata. It tells us who the owner of a particular sequence is, its increment value, basically all of its metadata. No big surprise there. If you know the specific name of an object, you can just craft that into your query. This next example we're looking at on line 13, we're going to drill into a data dictionary view dict underscore columns that contains, as you can expect, metadata pertaining to every column in every table, view, or other object. You'll find that describe functions similarly to the dict columns view. Let me run this just to verify it, and you'll see the same information, column name and comments. A little bit different, I suppose, than running a describe. Again, run describe gives us our data types, our columns. Dict columns just has the column name and any optional comments we've supplied. Why don't I use my SQL worksheet control, pop open a connection as HR, and run some data dictionary queries as the HR user. I'll select both of these guys, copy them to my clipboard, switch over to HR, and paste them in. Remember, our user underscore objects gives us the ability to query objects that we own, and we know that HR does own some objects, so we'll run from user objects a select that grabs object name, created, last DDL time, and status. And there's a pretty good list here. Now you probably want to pare this down a little bit more with a where clause, because you notice, this fetch 50 rows, but you see if I scroll down, it grabs more and more rows. There's a lot going on here. You have to remember that an object isn't necessarily just something like a table, like you see T10 and T11 are tables we've worked with before. Emp details view is a view. You'll also find constraints show up as separate objects as well. There's IX for an index. That's yet another kind of object. PK is a primary key constraint. I hope that in querying the data dictionary views, you're starting to see how important it is to name your objects as descriptively as possible. Now, to see everything that's in the user objects view, of course, we can run a select star if we want to, just to see all the columns in action. Object type is going to give us a nice descriptor of what those are. So why don't I recast this query as select object name, object type, from user objects. There we go. So this will give us a little bit more detail. We have some sequences, we have a procedure, trigger, a nice healthy sprinkling of different object types for this user. I find it very useful to use user, DBA, and all just so you have a better idea of scoping. There's a lot here, so we want to craft our queries intelligently enough such that we don't get back too much information. Now, if I'm running this same command from all objects, we're going to get some more, presumably. Yeah, we're into the 200s, it looks like, in terms of rows, 450 rows back. Remember that all objects, or any of the all underscore data dictionary views, will give us metadata on objects that we have access to. So we, as an ordinary HR user here, can query any of these dynamic performance views. We have privilege to that. And I also want you to see that these $V dynamic performance views don't show up as object type view, but actually show up as object type synonym. This is kind of an under the hood point, but the $V and then friendly name is just a built-in synonym for the actual view. As you see here, views in Oracle for some reason are actually called $V underscore dollar and then the name. So it's just a little helpful pointer for you to consider. Another example that we can run in the context of HR, if we want metadata regarding constraints, yet again, it's typically just the prefix underscore and then the name of the object that you're interested in. Here we're looking at some columns to describe constraints on objects that we own. Let me bring up the split bar. Tells us what kind of constraint it is, what its name is, its status, and its table name. status checks are a big reason why you would query the data dictionary directly, for sure. As far as dynamic performance views are concerned, we'll come back to our sys tab here, run these under the context of our super user account. It's a question of figuring out what question you have or that you need an answer for regarding performance data, and then crafting a query. Now, we've been just using single view queries here for the data dictionary and these dynamic performance views, but sometimes you can get some columns from one view and other columns from a related view, so joins are infinitely possible with the data dictionary. This first query is going to answer the question, who are the currently connected users to the database? We can query vsession for that, $session, and we're going to bring back these properties where the username is not null, so only when there actually is an honest-to-goodness user connected to my server. And you see that we have HR and sys, sure enough, but we also have various processes that comprise the Oracle instance that are connected as well. Sysman, DB, SNMP. Depending upon the processes and services that are enabled, we have other users who are actually the computer itself. You see that a couple of them are Windows services that are running under the authority of the operating system itself. Finally, I've just run simple select splats against other common dynamic performance views. $control file will tell you everything you want to know about your control file. $instance give us a lot of metadata about our product version, last startup, the status of the database, its instance name, its instant number, a lot of really cool metadata in $instance. $database gives us information about the database. And if you're wondering what is the difference between an instance and a database, I'm yet again, although I know I sound like a broken record, going to refer you to my DBA1 training where we get into that subject to a great degree of depth. $process gives us everything we wanted to know about the Oracle processes, the background processes, and $parameter shows us the current state of our initialization parameters. Really useful stuff, there's no question about it. Now I'm going to finish this demo by popping out onto the web and show you some sources where we can read more in the documentation on the data dictionary. Of course, the best place to go of all when we're studying for an Oracle exam is the Oracle reference itself. I know we're going to do a separate nugget to conclude this series on the documentation, but I wanted to show you in the Oracle documentation we have a document called the Oracle Database Reference, and this is going to be everything you wanted to know about your static data dictionary views as well as dynamic performance views. Literally gives you an alphabetized list of all of those. Let me just jump into a page representarily, and then we can hit next. We can navigate through these using the left-hand side, or we can go down, and it basically gives you a breakdown of each one of those views. It saves you having to run a describe on them. The idea here is we can take a look at what columns are comprised in each one of these views and then start mixing and matching. Another site that I tend to use a lot as a quick reference is ss64.com. This is a page underneath that site. The virtual directory name is ORAD, and it's a dump of the Oracle Data Dictionary. They also have a separate page, which I'll open as a separate page, or a separate tab, I should say, that gives us all of our $$ views. And again, these are all hyperlinked and tell us just very simply what the columns are in each. So it's a much faster way to work than the Oracle documentation, but it only gives you the column names here instead of the data type as well, which is just as well in most cases. I'd like to complete this demo by showing you how we can access the data dictionary through SQL Developer and Oracle Enterprise Manager. Through SQL Developer, it's pretty much transparent. We can use our connection list here, which is going to be filtered for the user. Obviously, the sys user can see everything, whereas, say, Scott or HR can see only those objects to which they either own or have access. At any rate, and I'm just opening up Scott's sample schema just for grins, we'll take a look at one of his tables. By selecting an object from the connections list, we've visited this before several times, that SQL Developer gives you a tabbed interface that gives insight into just about any aspect that you want to learn about for that object. Specifically, though, for metadata, you'll want the details column. And the specific details that show up for your objects are going to be dependent, of course, on the object in question. In this case, looking at this bonus table, it gives us the created field, last DDL time. In other words, when the object was created, owner, which table space the table belongs to, view, its status, its storage information, and then you just go on and down, whether there's dependencies, compression, etc. And then just to demonstrate that we can access the Details tab for any object, let me select one of Scott's indexes, and again we have a Details tab that gives us the same, largely the same, properties transparently pulled from the data dictionary. Now let's fire up Oracle Enterprise Manager. To do this on a Windows Oracle server, we'll fire up Start, open up our Instance folder off the Start menu, and then select Database Control for the database in question. We're going to log into Oracle Enterprise Manager as the sys super user. I'll put in my password, and we need to make sure we're connecting not with normal privilege, but as sysdba to get full access. The whole enchilada, as I sometimes like to say in my life. Depending upon how loaded your server is, it may take a while for some of these charts and graphs on the home page to show up. But really, any statistics you see here are being pulled directly from the data dictionary tables. In many cases, for instance, you see information regarding active sessions, CPU utilizations, and it hasn't shown up yet, but it's currently loaded. All of that is being generated by means of, you guessed it, dynamic performance views. If we navigate to the Performance tab, this tab and everything in it is certainly connected directly to the dynamic performance views. The Schema tab, where we can look at schema objects in the database. Oracle just shows us the information. We just click on it, but sure enough, behind the scenes, we have calls to the data dictionary coming to the forefront. For instance, under Database Objects, I'll select Tables, and I'll switch the schema in question to HR. Click Go, and these are the HR tables. No big surprise here. And we can select one of those tables, and it gives us a full columns list, constraints, indexes, which are themselves hyperlinked, storage information, and we can use simple GUI controls here to get to other aspects of the data dictionary. The data dictionary review. The reason I placed this nugget so far back into the training is because it leverages or requires knowledge of everything we've learned up to this point. I don't think somebody can really appreciate the power and utility of the data dictionary until they've spent time in Oracle and have an understanding of schema objects, schema security, and so forth. So at this point, you should understand what the data dictionary is, how it's laid out, and we know how to access the data dictionary, both our static views as well as our $$ dynamic performance views as an ordinary user, and how that level of access to data dictionary is different from access by the DD owner, namely sys or any other DBA. I hope that this has been informative for you, and I'd like to thank you for viewing.